Uh, Hello everyone. So today we are looking at the problem sort zeros, ones, and twos. So this problem is also available in LeetCode as sort colors. So we are given an array which contains only zeros, ones, and twos. So we need to sort the array in ascending order. So we can consider red color as zero, white as one, and blue as two, right? So we have some sample example test cases over here. So yeah, we need to sort all of the zeros, ones, and twos in ascending order. We are only given zeros, ones, and twos. So we can take up the brute force example. So I have taken the same example over here. So one approach which comes to my mind immediately is I can maintain count right, like count of zero, count of one, and count of two. So I can like traverse the entire thing and maintain all the count of zero, one, and two, right? So yeah, this is going to be quite an easy approach. I can just write for int num of array. Like this is just a pseudocode. If array of if num is equal to one, then count one plus plus else, and I can write this right. And after that, I can once again start in the same array, like traverse it, and then just fill it right. Like how many count zeros we have, then one, and then two. So I think the brute force approach is clear. But now we need to understand about the optimized approach. So actually we can solve this question in one pass itself rather than two passes. So yeah, this is also known as DNF, Destination Flag Algorithm. So let me just take up. So the first thing that we need to understand why there is an optimal approach is we can just imagine that ultimately we will have zeros, ones and twos, right? Like this will contain the zeros. This thing should contain the ones, and this thing should contain the twos, right? So I can get this end very easily, and this end also very easily. But what matters is this end, right? These two. So I need to be somehow able to get these twos and make some sort of swaps so that finally I can obtain this kind of state. So that is the basic idea. So what we can do is actually for maintaining zeros, we can use a pointer. Let's call it low. For maintaining the ones, I can maintain some pointer called mid, and maintaining the twos, I can maintain some pointer called high, right? So I have made these three pointers. So what I will do is I'll keep the high at two. Just a second, I'll just move it. Yeah, so I have kept the high at the end, the low at the start, and since this is unsorted, so I might need to start from somewhere, right? So I'll keep the mid maybe at the starting position. Then what I can imagine is, acha, now low and mid, here there is a zero, so I should be fine, right? Like what I can do is I can just move this thing forward, like comfortably. For now, I'm just moving the low also because I'll just explain it in a minute. So now I have found a one. So what I can do is I can, I can just swap this. See, since this is the one, so what I can do is I can move directly mid forward and maintain the low as it is. Now again I have found a 1, right? So I'll just move this forward. Now here since there is a 0 and I know that 0 should come behind. So I can just swap these both, the low and the array of low and array of mid. Now after swapping this, I also have to make sure that now I will move the low pointer also. So this was the reason why I had initially moved it. So low will be actually maintaining the just end position. So if I ever find any 0, I can just directly swap it here, right? So now I can move this also forward. Since this is the 1, I will move it forward again. Now I have found a 2. And at the end, what we actually have is a 1. So since if I have found here a 2, I can guarantee, I want to make sure that 2's are always at the end, right? So what I can do is I can make sure that 2 is at the end. And since now 2 is guaranteed to be at the end, I can decrement the high. But I might not know what here is. So I'll just maintain the mid position as it is. Just remember to maintain mid as it is swapped with high. Now again I have to check at the mid. So this is 1, right? So I can just move it forward. This is a 1, I can move it forward. Now I have found it 2. I will swap these both and decrement high. Now this is a 0, right? So I can just swap these both and move both forward. Now again I have found a 0. I can just swap it, move both forward. So if mid is equal to high, then also I have to check right. So now I have again found a 0. I can just swap this and move both forward. Now since mid has crossed the high, we have thereby sorted the entire array. So yeah, I have written the code actually here, as you can see. This is not necessary, but I have just written it for clarity. If array of mid is equal to 0, then I'll swap and I'll increment both. Else if it is 1, then I can just move forward directly without any check. Else, if I get a 2 at array of mid, then I will decrease high, like I'll swap it and I'll decrease high also. But I will not increase mid. So this is the main important point, right? So as you can see, all the test cases pass very easily. Yeah. So that's it, everyone. Thank you so much.